Hello students, welcome back. In this part, we are going to study about the chord of contact and director circle. Although director circle is not actually a concept but it is a question of locus, but because it has been used so extensively that we are going to study it as a concept. So let's begin. Let's start with a different concept, that is the point of contact. Now suppose that there is a point P x1 y1 which is outside the circle. Now as this P point is outside the circle, so what I can do is that from this point I can draw two tangents. Let's call them PA and PB. Now this A and this B are nothing but the point of contact of these tangents. If I join this AB and if I produce them, then this straight line is called as chord of contact with respect to this point P x1 y1. So its equation, we are interested in finding out its equation. Its equation is given by T is equals to 0, where we know what is T. T has its usual meaning that we have in tangents. So T equal to 0 from a point that is outside is a chord of contact. So remember that T equal to 0 has two different forms. If the point is on the circle, it is a tangent. If the point is outside the circle, it's a chord of contact. Now let's do a question on this. Suppose that if the chord of contact of tangents drawn for 2, we are drawing tangents to this circle, okay, and chord of contact of this circle drawn from any point on this touches this circle. That means there are three circles, okay. The first circle, that is the outside one, is this x square plus y square is equals to a square. The second circle to which we are drawing the chord of contact is x square plus y square is equals to a square. From this circle, we are drawing chord of contact to this circle, which is AB. This AB is chord of contact. This AB is touching this circle, x square plus y square is equals to c square. AB is touching this circle. So we need to find out this relation, that whether this relation holds or not. We need to show this. So let's say that there is any point x1 y1 which lies on the circle x square plus y square is equals to b square, or I can say that because this point lies on this circle, then x1 square plus y1 square is equals to b square. Now from this point we have drawn chord of contact to this circle. So equation of chord of contact to this circle will be what? T is equals to 0. That means x1 plus y1 minus a square. This is the equation of chord of contact, okay, to this circle. Now this chord of contact touches this circle. That means perpendicular from its center, which is 0, 0, perpendicular has to be equal to its radius, which is c. So perpendicular to this, that means 0, 0. So minus a square divided by root of x1 square plus y1 square, that is perpendicular distance from 0, 0 to this line is equal to c, okay, is equal to c. That now, but x1 square plus y1 square is b square, so minus a square by b mod is equals to c. That means I can say that clearly a square is equals to bc. So the question was very simple. It's just that those three circles may confuse you, but the question involves a trick, that you have to draw the three circles and you have to imagine. This diagram is very important here. But so if you can draw the diagram and if you know the concepts, and it's about confidence, because when the students sees three circles, they fumbles or they thinks that the question is difficult and let's leave. But if you can draw this diagram, then the question is very simple and you can clearly see it. Proceed step by step. That's the funda. And let's move to another important thing, that is director circle. A director circle is nothing but locus of point from where perpendicular tangents can be drawn to a given circle. Let's suppose that we have this point h comma k. Again we can draw the two tangents from this outside point. If these two tangents are perpendicular, so we need to find out the locus of this point h comma k. What can happen is that I can draw two tangents from here as well, okay. It will depend on this distance from this, it will depend upon distance of this point from center. Okay, so this can be perpendicular. Similarly, there can be lots and lots of points which will be perpendicular. So let's see how we can do. We know that the equation of tangent is y equals to mx plus minus a of under root 1 plus m square, where a is your radius. So that means equation of this circle S is x square plus y square is equals to a square. Now if this is the thing, then what I can do is that I can take this mx this side and I can square. So y minus mx whole square is equals to a square of 1 plus m square. Okay, that means y square plus m square x square minus 2mxy is equals to a square of 1 plus m square. Now we are interested in, this is a quadratic in m, so we are interested in the values of m, because we know that m1 into m2 is minus 1. Okay, so we are interested in m1 and m2 values. That means we want, if this is a quadratic in m, then m1 m2 minus 1, that means the product of the roots has to be minus 1. So let's form the quadratic m square of x square minus a square, okay, minus 2mxy plus y square minus a square is equals to 0. Now you can see that this is a form of quadratic in m. It has two roots m1 and m2. Product of the roots m1 m2 is c by a. So this is c, y square minus a square, this is a, divided by x square minus a square is equals to minus 1. That means the equation comes out from here is x square plus y square is equals to 2a square. That means that the locus of point of intersection of perpendicular tangents is nothing but a circle, which is this S dash. Okay, and this S dash has a radius root 2a times the radius of S. Okay, you can see that the radius of this S is a square and radius of our director circle is 2a square. So radius of director circle is equals to root 2 times radius of the circle, that you know. This is a very important result and you need to remember this always. What is the director circle and what is the radius relation? Let's move to one more question. Suppose that there are two tangents PA and PB drawn to this circle from the point 3, 0. Obviously if you are drawing two tangents, that means the point is outside. We need to find out the area of triangle PAB. That means this is P, this is A, this is B. We need to find out the area of triangle PAB. This circle is x square plus y square is equals to 4. That means its radius is 2. Okay, radius is 2. That is the information. Center is 0, 0. I can find out the equation of AB because AB is nothing but chord of contact. Equation of AB will be 3x plus 0y minus 4 is equals to 0. That means equation of AB is 3x is equals to 4. Okay, and you can clearly see that O is 0, 0, P is 3, 0. That means OP and AB are perpendicular. Now we need to find out the area of triangle. So del will be nothing but, if you take AB as base, then half of AB into PD. So we need to find out the values of AB and PD. How can we do it? If this is the equation of AB, that means we know that OD is nothing but 4 by 3, okay, and PD is nothing but D. This is the PD is 3 minus 4 by 3. That means 5 by 3. Okay. Now we have PD. We need to find out AB. How can we find out AB? AB. We know that perpendicular from center to chord bisects the chord. This is perpendicular. Okay, because if this angle is 90, then this angle will be 90. So OD is perpendicular to AB and OD is perpendicular from center. That means it will bisect the chord AB. So AD and BD are equal. AD is equal to BD. Now in the triangle OAD, it's a right angle triangle. So I can say that AD square by Pythagoras theorem is equals to OA square minus OD square. So OA square is what? OA is nothing but the radius, that means 4 minus OD square. OD is what? Value of OD is 4 by 3, that means 16 by 9. So in this way this comes 36 minus 16, that is 20 by 9, or the value of AD is 2 root 5 by 3. Okay, this is AD. So if this is AD, then AB is what? 4 root 5 by 3. We have the value of AD, we have the value of PD. Area of triangle will be, sorry, this is AB. Area of triangle will be AB, that is 4 root 5 by 3 into PD, that is 5 by 3. So the answer is 10 root 5 by 9. This is the area of triangle. So this is it about this part. I hope that the concepts are understood to you. Now remember the condition of directed circle. It is very important. Now in the next part, we will start with how many tangents can be drawn from a point that is outside a circle and its different cases. Thank you for watching.